Hello students, myself Archana Varude from Praveen Patil College of Diploma Engineering and Technology. In this video, we are learning about definition of viscosity, what is meant by velocity gradient, and what is the statement of Newton's law of viscosity. Before starting the point viscosity, first see this diagram. Here it is observed that in this container there is a liquid taken, any liquid, for example water or glycerin. But when we see a streamline flow, that means a constant flow, then velocity of each particle is constant. But when we consider different layers, then it is observed that velocity of each layer is different. The layer which is nearer to the wall of container, it has minimum velocity, and the layer which is in the middle size has maximum velocity. Here we consider eta is the density of that liquid, and here when we consider two different liquids, then it is observed that the layer which has minimum velocity tries to oppose the layer which has maximum velocity. At the same timing, the layer which has maximum velocity tries to oppose its neighboring layer. That means there is a opposite relative motion between these two layers, and that property is called as viscosity. And from that we write the definition as it is the property of liquid on account of which liquid tries to oppose the relative motion between its different layers. Then what is meant by velocity gradient? For that, consider two layers, layer P and layer Q, and as we know that neighboring layers has different velocities. Here we consider that layer Q has velocity V and layer P has velocity V plus dV. That means that layer has some large velocity as compared to layer Q. Then here dV is the change in velocity of layers, and these are the neighboring layers, but there is small change in vertical distance between these two layers, and that distance is denoted by dx. And therefore when we take the ratio of that dV upon dx, that means change in velocity to the change in distance, that is vertical distance between the layers, that ratio is called as velocity gradient. And therefore formula is velocity gradient is equals to dV upon dx. And we write the definition as it is defined as the change in velocity per unit change in vertical distance of liquid layers. Then we have to write the unit of velocity gradient. Here formula is dV upon dx, and as we know that unit of velocity is meter per second, and here dx it is the vertical distance between two layers, and unit of distance is meter, and therefore when we write unit of meter per second upon meter, then meter get cancelled, only remaining is 1 upon second, and therefore unit of velocity gradient is per second, that is written as 1 upon second. And this unit it is same in all the systems of unit, that is CJS, MKS and SI unit. Then what is the statement of Newton's law of viscosity? And the statement states that the viscous force, that is F, developed between two liquid layers is directly proportional to the surface area of liquid and directly proportional to the velocity gradient. Here viscous force means when we consider two layers, then it is the opposite relative motion between different layers, and due to that there is a frictional force present between liquid layers, and that frictional force is called as viscous force. And according to this law, that viscous force is directly proportional to, first is surface area and second is it is directly proportional to velocity gradient. Then we write the equation. Here F means viscous force directly proportional to surface area and directly proportional to velocity gradient. And for velocity gradient, equation is dv upon dx. Then in next step, when we consider equal sign, we get F equals to eta A dv upon dx, where eta is constant and that eta is known as coefficient of viscosity, and that eta is constant for a given liquid and it changes from liquid to liquid, and its meaning is that eta is not same for all liquids. If the liquid changes, then value of that eta changes. And from that we write formula for coefficient of viscosity is eta equals to F upon A dV upon dx, where F is viscous force, A is surface area and dV upon dx is velocity gradient. Now we write SI unit or MKS unit of coefficient of viscosity. Here in formula, in numerator quantity is F, therefore first write the unit of force is Newton. In denominator area, its unit is meter square and unit of velocity gradient is 1 upon second, and therefore final SI unit of eta is Newton second upon meter square. Then we write CGS unit of eta. Here formula is same, F upon A dV upon dx, but we have to write the CGS unit. Therefore write the CGS unit of force is dyne. For area, CGS unit is centimeter square, and for velocity gradient CGS unit is 1 upon second, and therefore CGS unit of coefficient of viscosity is dyne second per centimeter square. But it is observed that when we consider 1 dyne second per centimeter square, it is equals to 1 upon 10 Newton second per meter square, and which is also known as 1 poise. Therefore remember one thing, 1 poise means it is equals to 1 dyne second per centimeter square. Then from that we write definition of 1 poise, and before that first we write the formula for coefficient of viscosity is eta equals to F upon A dV upon dx. But if we consider that surface area is equals to 1, velocity gradient is equals to 1, then when we put the value of A equals to 1 and velocity gradient is 1, then we get eta equals to F. That means coefficient of viscosity is equals to viscous force, and therefore from that definition is the coefficient of viscosity is said to be 1 poise if 1 dyne viscous force is developed between two liquid layers of 1 centimeter square area for unit velocity gradient. Here unit velocity gradient means that value of velocity gradient is equals to 1. Then definition of coefficient of viscosity. Here see again, when A equal to 1, dV upon ds equals to 1, then eta equals to F. And therefore definition of coefficient of viscosity is, it is defined as the viscous force developed between two liquid layers of unit surface area for unit velocity gradient. That means when area is 1 and velocity gradient is 1, then coefficient of viscosity is said to be viscous force. Then now we solve MCQ on these PPTs. First question is the property of liquid on account of which liquid tries to oppose the relative motion between its different layers is called as. First option is A, viscosity, Option B is velocity gradient. Option C is both A and B, and option D is none of these. And as we know, the definition of viscosity is the property of liquid on account of which liquid tries to oppose the relative motion between its different layers is called as viscosity. Therefore, correct option is A, viscosity. Question number 2 is the change in velocity per unit change in vertical distance of liquid layers is called as. Option A is viscosity, option B is velocity gradient, option C is both A and B, and option D is none of these. And as we know, the definition of velocity gradient is it is the change in velocity per unit change in vertical distance. And therefore, correct option is B, velocity gradient. Question number 3 is the coefficient of viscosity denoted by. Option A is eta, option B is theta, option C is omega, and option D is delta. And see here, the coefficient of viscosity is denoted by the symbol eta, and therefore here correct option is A, eta. Question number 4 is the viscous force developed between two liquid layers is directly proportional to the surface area of liquid layer and directly proportional to the velocity gradient. It is a statement of. Option A is Newton's first law of motion, option B is Newton's second law of motion, and option C is Newton's law of viscosity. And as we see in this earlier slide, that Newton's law of viscosity states that the viscous force developed between two liquid layers is directly proportional to the surface area of liquid layer and directly proportional to the velocity gradient. And therefore, here correct option is C, Newton's law of viscosity. That's all about today's video. I hope you all understand about viscosity, velocity gradient and Newton's law of viscosity. Thank you.